All right, we're going to be looking at the Inquiry Lab area of parallelograms. It starts on page 657. It should look like this. If you have graph paper and you'd like to do the little hands-on activities that they're talking about, you might want to get out a piece of graph paper before we begin. All right, so to start, it says that how does finding the area of parallelogram relate to find the area of a rectangle? Elise wants to make a banner in the shape of a parallelogram. Her parallelogram has a base of 2 feet and a height of 3 feet. What is the area of her parallelogram? So it says that another type of quadrilateral is a parallelogram. A parallelogram is opposite sides parallel and congruent. So just like our rectangles and squares where we have opposite sides that are congruent, we have that with parallelograms as well, that these sides are the same and these sides are the same length. These sides are the same, these sides are the same length. These sides are the same, these sides are the same length. So those are parallelograms where they have parallel sides that are congruent and as well as parallel. Now, not parallelograms, obviously, are anything that don't have, oops, sorry about that, are any ones that do not have sides that are the same length on both sides. So obviously you can see that this length and this length, they are not the same. As soon as you see that one set of sides are not the same, then you can stop. Now these two are parallel, but they are not the same length because these two are coming inward, and so they're not the same length. So those are not parallelograms because they don't have parallel sides that are congruent. So to make a parallelogram to represent Elisa's banner, we're going to start with a rectangle and trace the rectangle shown on the right. So they're saying 2 feet by 3 feet. That was her base 2 feet, height 3 feet. And so if we want to make this into a parallelogram, what they're saying is let's cut a triangle from one of the sides. So we're going to take like a triangle from over here, kind of cut it out this way, take this and glue it to the other side. So you see how they did that in this picture. They took the triangle that they cut from over here and they pasted it over here. So now this is gone and it's now been attached over here. So it says cut a triangle from one side of the rectangle you traced and move to the other side to form a parallelogram. Tape the parallelogram to the right. Alright, so now our shape is more like this than it was before. But notice that the area is still the same, right? Like I didn't take a piece and cut it out and not return it to the form. I just kind of cut and pasted it over to here. Alright, so now here's my new parallelogram. And it says that the rectangle was rearranged to form the parallelogram. Nothing was removed or added to, so the parallelogram has blank as the area as the rectangle. So what you should be writing here is it has the same area. Okay? The same area as the rectangle. So if we're multiplying the base times height like we would to find the area of a rectangle, the base we said was 2 and the height is 3, and so if we do 2 times 3 we get 6 square feet is the area of the rectangle, which is also the area of this parallelogram because it has the same amount of space. I have all of this still right here. I just took a little piece over here and then glued it to the other side. Alright, so it says find the area of the parallelogram below. Step 1, trace the parallelogram on the grid paper and cut it out. So if you'd like to draw this onto a piece, you could. If not, just visualize with me here. And so they cut this piece out. Then they said to fold along the dotted line here. So from here all the way straight down, we're going to fold. It says to move the triangle to the right and tape it so that the rectangle is in the space provided. So notice that we took this little triangle from here and we're going to put it in over here. So now we've got a shape that looks like, let's see if I can do this. Not great. But here we go, good enough. So now we have what looks like either a square or rectangle. And they want us to count the number of square units of the rectangle. So I would go through and just figure out how much it is long. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 this way. So 10 units this way. And then 1, 2, 3, 4, 5, 6, 7, 8, 9 units this way. And so if I was to find the area and add up all the units that are in the inside here, it would be 9 times 10, which is 90 square units. Alright, I'd like for you to do hands-on activity number 3 on your own, and then we'll come back and see if you got the same answer as I did. So follow along with the step-by-step directions and make sure that you know what you're looking at. Alright, so what you should have done was, step 1 says to trace the parallelogram and cut it out. It's up to you if you want to do that or just kind of draw it as you go. It says to fold the cut along the dotted line, so right down here, and then move the triangle to the right side provided. So I'm going to take this and it's coming over here. And so now I have this, it looks like they made a smaller shape here. This, this, and this. So I've got 1, 2, 3 this way, 1, 2, 3 this way, and actually it looks like I made a square here, and you should have 9 square units as your final answer. The area of this parallelogram that we transformed into a square in this case became 9 square units. Alright, that ends our section on Inquiry Lab for our finding the area of a parallelogram, and we'll carry on tomorrow in class. I'll see you then. Short video. Yay!